At number 4, question number 16 to 20. An online survey was conducted by a marketing research company in which lakhs of people participated. The survey asked participants which grocery delivery apps, Blinkon, The Basket, and Instagrow they used. Everyone who participated in the survey used at least one of these three apps. 88% of the people surveyed said that they use Blinkon, 87% of the people surveyed said that they use The Basket, and 71% of the people surveyed said that they use Instagrow. So this question looks like a question on set theory. Let's look at this set looks like a set theory question. Let's look at the questions and understand as to whether it's a set theory or whether it is a question based on percentage or it's a reasoning based DI. So the questions that we have are, what could be the maximum value of people who used all three apps? What could be the maximum value in percentage of people who used exactly two of the three apps, exactly two of the three apps for question number 18 as well, minimum value who used all the three apps, and so on. So this is a set. This is a set theory question, okay? And this is an advanced level. Advanced level as in we need to minimize or we need to maximize exactly one, exactly two, all of that, none, whatever is given. This was also very much understood because the amount of information given to us is not good enough. So drawing Venn diagram here is not going to be helpful at all. So we will have to look at the questions individually and then proceed. The approach that we are going to use over here is going to be called as token or chocolate distribution method. This is a very smart method and it helps us solve questions very, very quickly. So CDM. Now for this, we are going to assume that there are certain number of students, okay? The students is going to be the total number of people we have. Since the question is based on percentages, so our assumption is going to be there are going to be 100 students. We can take any number, but 100 is going to be easier. So for Blinkon, we will use the letter B and we will say 88 students, they like chocolate of B type. For the basket, let's use the letter T. 87% of 100, which is 87 students, they like chocolate of T type. And for Instago, let's use the letter G. 71% of 100, which is 71 students, they like G type chocolate. So these are the number of chocolates and types of chocolates we have. So the total chocolates, if we add, is going to give us 246 chocolates. That's what we have overall. Okay. So we will be drawing line diagram. The only rule over here that we have to understand is no student should get more than one chocolate of a type okay. So if a student gets two chocolates, both the chocolates should be of different types. So they can be B or B and T, they could be T or G, T and G, or it could be B and G. Okay. And also, since it says everyone who participated in the survey used at least one of these three apps, this tells us a condition wherein none is going to be zero. As in there is going to be zero student who is not going to get any chocolate. So we have to make sure all the 100 students should get a chocolate. Okay. So let's move over to the questions and see how we should solve them. Question number 16. What could be the maximum value in percentage of people who used all three apps? So let's assume these are those 100 students and they're standing in the queue. And we have three types of chocolates, if you remember. So the first one is the B type of chocolates, which are a total of 88. And then we have T type of chocolates, which is 87. And then we have G type of chocolate, which is 71. We have a total of 246 chocolates overall. So we need to distribute these 246 chocolates among these 100 students, right? Okay, so this is how we will proceed. Since we need to find out the maximum value in percentage of people who use all the 3 apps, okay, so the maximum number of people we can have is, we can see that there are 246 people. So we are going to distribute 1 chocolate to everyone. Why do we do this? Is because every student should get at least 1 chocolate. Remember, none is 0, which means there is nobody who is not a participant of the survey. Everybody is a participant and everybody answered one of the 3 types of chocolates, right? So it's, instead of apps, we are talking about chocolates here. Okay. So out of 246, 100 has been removed. So we are left with 146. Now, if we want to maximize the students who will have all the 3 types of chocolates, each student so far they have 1 chocolate. So what I will do is I will give the next student 2 more chocolates, right? Because the maximum number of apps any student can have, any person can have is 3. That means the maximum number of chocolates any student can have is 3. So I'll give every student 2 more because they already have 1 each. So if I keep on doing this, giving every student 2 more, to how many students will I be able to give 2 more out of these 146? So obviously 146 divided by 2, which is going to be 73. So we will be able to give 73 kids 2 more chocolates. They already had 1. So we can say the maximum number of people who can use all the 3 apps is going to be 73, right? But here is the catch now. The catch being, if we have G type of chocolate, the smallest set 71, how come it be 73? So whenever we have a clash like this, we will go ahead and use the value which is the minimum out of these. So the smallest set we have is 71, which is smaller than 73. So we should have none of the above, as in there are going to be 71 students out of 100 students who can use all the 3 apps. Instead of distributing the chocolates, please remember, whenever you have such a question, the answer is always going to be the smallest set. Okay, it's in very rare scenarios, it won't be a smaller set. Suppose the distribution would have taken us, instead of 73, as just 70. So we would have chosen 70. Okay, so the answer is going to be D, none of the above. Question number 17. What could be the maximum value in percentage of people who used exactly 2 of the 3 apps? So we need to maximize the number of people number of students who will have exactly 2 chocolates. Well, it is pretty simple. If I want to maximize the number of students, let's assume each student has 2 chocolates out of 246. So we will give every student 2 chocolates each. We have now all the students who have exactly 2 chocolates. So exactly 2 of the 3 apps, there are 100 people or 100% of the people that will have. But remember, we don't have 200 chocolates, but we do have 246. So that means we are left with 46 more chocolates. What to do with these 46 more chocolates? We are supposed to give those 46 more chocolates to the first 46 kids. Okay, it's not necessary that they need to be the first 46. They could be last 46 or any random order. But it doesn't matter in which way we are going to distribute it. We will always have some 46 students out of 100 students who will have 3 chocolates, right? So we can say that out of 100, these remaining students, which will result in a total of 54, who will have exactly 2 chocolates. And there is no way we can maximize this further, because in order to maximize this, we will have to give chocolates to the initial, any of the 46 students. That will make somebody have 4 chocolates, and the moment they have 4 chocolates, the basic condition that nobody can have more than 1 chocolate of a particular type, that fails. So this is where we need to stop. Since the question was a theta question, so we had to type in the answer 54. So 54 is going to be our answer. Question number 18. What could be the minimum value in percentage of people who used exactly 2 of the 3 apps? So we have these 100 students with us, and the types of chocolates we have are the very first one, which is B, which is 88. Then we have the next type of chocolate, which was T, which is 87. Then we have G, which is 71. We have a total of 246 chocolates, right? Okay, so the minimum value in percentage of people who used exactly 2 of the 3 apps. So we need to minimize now, right? Students who will have exactly 2 of the 3 apps. So in order to do so, what we will do is we will give everybody 1 chocolate. We will give everybody 3 chocolates, but we will give none of them 2 chocolates. So that should be our target. So initially we are going to give everybody one chocolate. It is necessary as we cannot leave any student without any chocolate. That was the prerequisite condition given in the main part of the set itself, right? So out of 246, 100 chocolates are done. We are left with 146. Now our target is to finish the chocolates as soon as possible, and we can't give anybody 2 chocolates, as in we cannot give 1 more chocolate to any student, because then that student will have 2 chocolates. And we need to minimize it. Our target is to keep that as 0 students. So what I will do is I'll give the first kid 2 more chocolates, the next kid 2 more chocolates, the next kid 2 more chocolates, and this continues. Now, when this happens, just like the first question, question number 16 of this set, we will be able to do this to a total of 73 kids. Now, 73 kids are going to have 3 chocolates. But the smallest set we have is 71. That means 71 people can only have 3 chocolates, which we already know from question number 16. So that means this 73 is not going to happen. We will have only 71 students who will have exactly 3 chocolates. Now, since 71 kids are going to have exactly 3 chocolates, that means we distributed 2 chocolates among 71 kids. That means we distributed 142 chocolates out of 146. That means we are left with 4 more chocolates. Those 4 more chocolates, unfortunately, the only way we can distribute is by giving 1 to the next 4 kids, because we can't distribute 2 more. They already have 1. So the only way we can give them is by giving them 1 each. Right? So there are going to be exactly 4 kids minimum who will have 2 chocolates, exactly 2 out of 3. Now, since this is in percentage, 4 out of 100 students, that will result in 4%. So the answer is going to be option B. Question number 19. What could be the minimum value in percentage of people who used all the 3 apps? Now here we need to minimize the number of people who will use all the 3 apps. So what we will do is we will give everybody 2 chocolates, 1 chocolate, but we will prefer not giving anybody 3 chocolates. So for that, we will give everybody 2 chocolates. Why not 1 chocolate? Because we need to get rid of all the chocolates as soon as possible. So the fastest is to distribute as many as possible. Right now, the maximum we can distribute is 2 chocolates. So out of 246, if I give 100 students 2 chocolates each, that means 200 chocolates are done and we are left with 46. Now these 46 will anyways go to the first 46 kids, such that exactly 46 kids are going to have 3 chocolates, and we won't be able to minimize this, right? We can't make it 45. In order to make this 45, the remaining chocolates will go to some other student, which will include that student instead of the one that we just took out. So the minimum is going to be 46 out of 100 students who will have exactly 3 chocolates or exactly 3 apps. So 46, B option is the answer. Question number 20. What could be the maximum value in percentage of people who used exactly one of the 3 apps? So we need to maximize the number of people who will use exactly one of the three apps. In other words, we need to maximize the number of students who will have exactly 1 out of 3 chocolates. So if I want to maximize it, my target is that everybody should have exactly 1 chocolate. So that maximum is 100. But we have not yet distributed all of the chocolates. We are still left with 146. Now, if you remember the 2 questions from the same set previously, what we now do is we divide 146 by 2, which will result in 73. As in, the next 73 kids will have 2 more chocolates, such that 73 kids have a total of 3 chocolates with them, and the remaining 17 kids will have a total of 1 chocolate. So this is how we distribute it. But since 73 is greater than 71, this is not possible. So for this, what we will have to do is we will change this 73 to 71. So we will minimize it. Now, when we minimize it, such that only 71 have 3 chocolates, because that's the maximum kids you can have 3 chocolates, because the smallest set is 71 out of 88, 87 and 71, right? So we were able to distribute 142 out of 146 chocolates. That means 146 minus 142, 4 more chocolates are left. Those 4 more chocolates will go to the next 4 kids. So out of 100 students, 71 kids will have 3 chocolates, 4 students will have 2 chocolates, and the leftover kids will have exactly 1. And this is the maximum number of kids that we will be able to get who have exactly 1 chocolate, which is going to be 25. 71 plus 4 plus 25 is 100, right? So if we need to minimize the number of students having exactly 1 chocolate, our target was to finish the chocolates as soon as possible. And this is the only way we could have done it. Since it was a theta question, we were supposed to type in 2 and 5, 25.